Okay, let's pick up where we left off last time, which is the question about how our knowledge about specific people acquired through perception and learning experiences gets represented in memory. And last time I made the case that you can think about knowledge about a particular person as being represented in memory in a kind of associative network structure where we'd have a node that represents the person, in this case James Bartlett, and then there'd be associative links fanning out to other nodes that represent various items of knowledge about this person. First, that his name is James Bartlett. Second, that he's kind, that he rescued a kitten, that he caused an accident, and that he's kind of thoughtless, and everything else that we know about him. Now, one thing you should note about this is that the knowledge we have about James Bartlett comes in two basic flavors. There's episodic knowledge about particular autobiographical episodes in Bartlett's life, that he rescued the kitten and that he caused the accident. And there's semantic knowledge about James Bartlett, which has to do with more abstract, context-free knowledge that he's a kind person. That doesn't refer to any specific episode, or that he's thoughtless, and that doesn't refer to any specific episode either. So within these kinds of knowledge structures, we've got both episodic and semantic person knowledge represented. And the next question I want to ask is how are these two kinds of knowledge related to each other? This is actually an old question, and it's a question of what's known concerning what's known as the schematic effects in person memory. And the general idea is, what's the relationship between them? There has to be some kind of relationship between them. And in particular, we want to ask how semantic knowledge about a person affects our memory for specific episodes in his or her biography, and how are, whatever those relations are, how are they represented in memory? Here's a very straightforward experiment that has explored some of these problems. Work that begins actually with a great British psychologist, Frederick C. Bartlett, that's what he looks like, who introduced the schema concept to the study of memory way back in 1932. And what Bartlett argued in his book was that memory favors schema-congruent knowledge. That is, if you've got some abstract, context-free knowledge about some person or place or thing, and you try to remember other specific facts, the things you're going to remember best are the things that fit in with the schema, information that can be assimilated into the schema. And it's a proposal that makes a great deal of sense. Bartlett was a wonderful psychologist, but he was not the greatest experimenter in the world. He didn't necessarily conduct methodologically airtight experiments. And as people subsequently worked on this problem of schema congruence, they got all sorts of different results. Some experimenters found that memory did in fact favor schema congruent memory. Other experiments found that there was no difference between schema congruent memory and schema incongruent memory. And in fact, there were some experiments that showed that schema congruent memory was actually not favored in memory. So there were a whole bunch of conflicting results that appeared in the literature. And it looked at, as people began to look at this more closely, that how your experiment turns out depends on the control condition you use. That is, how you define the opposite of schema congruence. The person who had this insight was Reed Hasty, who's now a professor at the University of Chicago, the business school, who developed a variant on the Ash impression formation paradigm to study the influence of broad abstract schema on memory for specific events. And the method in Hasty's experiments is to start out by presenting subjects with what's known as a trait ensemble, just like Solomon Ash did, a list of adjectives that ostensibly describe some target person. And the purpose of this trait ensemble is to induce in the mind of the subject a schema for what that person is like. Then, after that's done, schema then representing our prior knowledge, beliefs, and expectations about the person, then Hasty had the subjects study specific behaviors that were ostensibly engaged in by this person. And what he did was to systematically vary the relationship between the behavior and the schema. So some of these behaviors were schema congruent behaviors. They were exactly the kinds of behaviors you'd expect from that kind of person. I'll give you a concrete example in a minute. Others were schema incongruent behaviors. They're not at all what you'd expect given the kind of person you're studying about. And then there are some behaviors that were schema irrelevant. They just didn't bear on the schema at all. Here's an example. We use James Bartlett. I also have a favorite example here. That's a person named Judy. That's what she looks like. She was my first graduate student, Judy Harakevich at University of Wisconsin. So first we'll induce a schema about Judy by presenting an ensemble of traits that describe what she's like in the abstract. That she's intelligent, clever, bright, smart, quick, wise, knowledgeable, and decisive. You got a sense now of what Judy's like. Now I'm going to tell you some specific things about Judy's behavior. First, that she won the chess tournament. That's a schema congruent behavior. It's exactly what you'd expect of a bright, knowledgeable, sophisticated person. And that she attended the symphony concert. Again, that's a schema congruent behavior. It's what you'd expect from somebody who's clever and bright. But then here's another one. She made the same mistake 3 times. That's not at all what you'd expect from this kind of person. You'd think she's smarter than that. Or she was confused by the television show. Again, not the kind of thing that you'd expect. And then there are a couple of behaviors that are schema irrelevant. That Judy ordered a cheeseburger for lunch. Doesn't bear on the schema in any way. Or that she took the elevator to the 3rd floor. Again, there's nothing about taking an elevator to the 3rd floor that relates to the schema at all. So now the question is, well, after people have formed an impression of Judy and then studied these various kinds of behaviors, schema congruent, schema incongruent, and schema irrelevant behaviors, now we're going to give the subjects a test of memory and see which ones they remember. And the answer is that they tend to remember schema incongruent behaviors best. Next on the list are schema congruent behaviors, and finally, they remember schema irrelevant behaviors least well. So here we've actually got a reversal of Bartlett's theoretical claim that it's not that memory favors schema congruent behaviors. Well, it does. Schema congruent behaviors are remembered better than schema irrelevant behaviors, but it turns out that memory favors most schema incongruent behaviors. And you can see from this pattern of results exactly how you could get the mishmash of experimental results that came in the post-Bartlett research, depending on how you define your control condition. Now, Hasty had a psychological explanation for this that is both interesting and I think correct, and that is that schema incongruent behaviors surprise us. And because they surprise us, they demand explanation. How could somebody as smart as Judy be confused by the television show? So we make up something, okay? We try to explain this behavior, and that extra explanatory activity produces a deeper, richer encoding of that specific event in memory. Similarly, when it comes to congruent behaviors, the schema itself serves as a kind of retrieval cue. When I say, what did Judy do? You say, oh, Judy, she was the smart one. Let me think of smart behaviors, and the congruent behaviors come out. When it comes to schema irrelevant behaviors, they get neither advantage. They don't get the advantage at the time of encoding that's given to schema incongruent behaviors, and they don't get the advantage at the time of retrieval that's given to schema congruent behaviors. They just kind of fall through the cracks. You got a quick question?
Wouldn't it make sense that things that are different from ourselves will always be more congruent to the bad description, while things that are similar to us will be more congruent to the positive description?
Well, it all depends on...
If the Amish read the list, then they
Well, see, that's exactly the point. Okay, somebody reads this about an Amish person, or an Amish person reads it, he's bringing pre-existing knowledge, expectations, and beliefs to the memory problem, and he's saying, oh, so he's not as smart as he thought he was, or whatever. That extra explanatory activity is going to create a deeper, richer, more elaborate encoding that's going to be favored in memory. Well, it doesn't make the irrelevant relevant, but it does make it explicable. That's the idea. So here are just a couple more examples of this, varying the mix of schema incongruent, congruent, and irrelevant behaviors. And you can see this U-shaped function coming up all the time, where schema incongruent behaviors are remembered best, schema congruent behaviors remembered okay, and schema irrelevant behaviors remembered the worst. Okay, so that leads us to this general principle in memory. Those of you, none of you did, took an intro with me and make a big deal out of this, known as the schematic processing principle in memory, that the memorability of an event varies as a function of its relationship with pre-existing schemata. Okay, how knowledge about things in general affects knowledge about things in particular. Now, there's another approach to explaining this. It's not a contradictory approach. It's just really another way of thinking about this. That comes from Thomas Sowell, who's was then a psychologist at the University of Illinois. And he says, look, let's try to explain this pattern of results in terms of our associative network models of memory. So we've got this person node that represents Judy, and there are these behavioral items that are linked to this person node. And he says, look, it's not just that individual episodes are linked to a person node, but individual episodes can also be linked to each other. And that's what happens in the process of trying to explain schema incongruent results. So Sowell proposed that when you encode schema incongruent behaviors, two things happen. First, you get additional processing that forms links between and among schema incongruent items. Okay, so there's a link between Judy making the same mistake 3 times, and a link between that and Judy not understanding the television show. And then there are additional inter-item associations that are formed between schema incongruent items and schema congruent items, again, as a process of trying to explain what's going on. So if, as we think, people retrieve information from memory by tracing down these associative links, retrieval is going to favor incongruent items. And the reason for that is there are simply more associative links connecting to schema incongruent items than there are to the schema congruent items, and there are very few associative links that are connecting to schema irrelevant items. So you get a situation like this, where you've got congruent episodes in the dark circles, incongruent episodes in the light circles, and irrelevant episodes in the represented by the triangles. They're just these very impoverished linkages here, but now you've got the schema incongruent episodes linked to each other, and also the schema congruent episodes. The schema congruent episodes are not linked to each other. And then once you say, what did Judy do? You activate the subject node, you trace down these associative links, you're going to hit one of these schema incongruent links. Okay, and that's going to take you to schema congruent behaviors, but it's also going to take you to other schema incongruent behaviors. That's the general idea here, and it turns out that this model predicts very nicely the finding I just described. These are studies by Sowell that essentially replicate the hasty result, somewhat different stimulus materials, but again, schema incongruent behaviors remembered best, schema congruent behaviors next, and then schema incongruent behaviors the least. So again, you can begin to develop from this kind of information some kind of model about exactly how knowledge about a particular person is represented in memory. Okay, so again, what you've got here is the subject node, and then nodes representing these various kinds of items. Sowell's model makes another very interesting prediction, which is a prediction about priming effects. That is, what's the effect of recalling one episode in Judy's life on memory for some other episode in Judy's life? We measure priming here not by accuracy of recall, but rather by speed of recall, response latency, or reaction time. And he says, look, these priming effects are mediated by associative links. So you've got a node representing a person like Judy, fanning out to these nodes representing irrelevant episodes, schema congruent episodes, and schema incongruent episodes, and all these connections between them. What this means is that if you happen to recall a schema irrelevant episode, there's going to be no priming effect, right? Because there's no connection between these schema irrelevant nodes and anything else. However, if you recall a schema congruent episode, look at what's going to happen. Activating a schema congruent episode, activation is going to spread out to schema incongruent episodes. Okay, so you've got these direct associative links, and of course, if you activate a schema incongruent episode, then you've got these links to both schema congruent episodes and schema incongruent episodes. The prediction of this model is that you're going to see a particular pattern of priming effects, which is that recalling a schema irrelevant episode isn't going to prime anything because they're not connected to anything else. Recalling a schema congruent episode is going to prime memory for schema incongruent episodes because they're connected to each other. And recalling a schema incongruent episode is going to prime memory for both a schema congruent episode to which it's connected and other schema incongruent episodes to which it's connected. That's a prediction of the model. And when you do the study, you present schema incongruent, schema congruent, and schema irrelevant episodes and simply ask people, did this happen to Judy? It's a recognition test. You record their response latencies. You get a nice pattern of priming. So we've got here the prime type. Recall on trial 1 is either of a congruent or incongruent or an irrelevant item. Then the target item, the next trial, is congruent, incongruent, or irrelevant. And what you can see here is that when a prime is schema congruent, it facilitates recognition for schema incongruent items. There's a significant reduction in response latency there, but there's no priming effect. That's not a significant difference. There's no priming effect for other schema congruent items. The response latencies for schema irrelevant items are always serving as a kind of baseline here. But notice what happens if the prime is a schema incongruent item. Here, the schema incongruent items prime the processing of both schema incongruent items. You'd expect that, like primes like, but you'd also get priming for the schema congruent items. And the schema irrelevant items, as predicted, don't prime anything at all. Again, this is a pattern of results that is exactly what you'd predict if knowledge about schema congruent, schema incongruent, and schema irrelevant episodes in a particular person's life are represented in this kind of structure. It's a very, very, very nice demonstration of how we can use response latency methods to test theories about knowledge representation, how stuff is encoded in memory. Okay, so as far as we can tell, Hastie got it right at one level of analysis about why schema incongruent information is so well remembered. But Sowell, when he tried to translate this into implications for how knowledge is represented in the mind, you got nice evidence for precisely this pattern of priming events. And note that this is not exactly what you'd expect. If you were just going to come up with a associative network structure for person memory, you wouldn't necessarily come up with. I thought I had this fixed. All right, you wouldn't necessarily come up with a model like this, but it turns out to be this is what a person memory looks like. Okay, so now let's take the same kind of priming methodology and see what else we can find out about the structure of person memory. Because of these schematic processing effects, we know that person memory holds information about both a person's traits and about his or her behaviors. If I didn't remember, if I didn't have the knowledge that Judy is a smart, intelligent, witty, creative kind of person, I wouldn't be able to show the kinds of schematic processing effects I just demonstrated. So now we've got to flesh out our representation of people because we've got to have a node that represents the person, James Bartlett, Judy, whatever. We have to have nodes that represent the person's behaviors, rescued the kitten, took the elevator to the 3rd floor, whatever. And we've got to have nodes representing trait information, that James Bartlett is kind or thoughtful, that Judy is intelligent and witty and creative and all of that. So now the next question about representation is, how are traits represented in memory? And in particular, what's the relationship between the way a person's personality traits, broad, abstract, general characteristics like kind or thoughtless or intelligent, and specific behaviors like rescuing the kitten or causing the accident or winning the chess tournament? How are those things represented in memory? Okay. Here's one way, the way I talked about before. We've again got this node representing James Bartlett, and all we have are associative links fanning out from this node, connecting to other nodes representing both semantic trait information and episodic behavioral information, but these are independent of each other. So here's an associative link that connects to kind, and another one to thoughtless, and another one rescued the kitten, adopted the child, cursed the salesgirl, caused the accident, whatever. These nodes are represented independently of each other. Okay, that's a pretty good scheme, but there's another form that this representation can take, and it's one that is more intuitively appealing, and that is to say that our knowledge of specific behaviors are organized by our knowledge about a person's traits. So you might look for a situation like this, that here's a node representing James Bartlett, and then that fans out to a node representing one of his personality traits, that he's kind, another fan out to a node representing his thoughtlessness, and then nested underneath these trait nodes would be nodes representing specific behaviors that exemplify the trait in question. Rescuing the kitten and adopting the child, those are both kind things to do. Causing the accident and cursing the salesgirl, those are both thoughtless kinds of things to do, and this is quite a different pattern of memory. Notice, for example, what some of the implications of this very intuitively appealing kind of structure are. All right, you go away. The first is, if I ask you, what did James Bartlett do? A question using a methodology that we call free recall, you might expect a person to cluster specific episodes in James Bartlett's life by their trait implications. So you might expect a person to say, well, he rescued the kitten and he adopted the child and oh, he cursed the salesgirl and he caused the accident. To put those two kind events together and those two thoughtless events together in recall. This is a phenomenon called clustering in recall, and we do see it when people recall lists of words that can be organized by category. The question is, do we see it in person memory when the items are such as can be organized by personality traits? And the answer is basically no. Here's an experiment by Stanley Klein and Judith Loftus. Klein's a professor at UC Santa Barbara. Very straightforward experiment modeled after the standard person memory paradigm. So we've got, Klein has 20 behavior descriptions, 4 for each of 5 traits. The traits in question are athletic, intelligent, honest, religious, and sociable. So there might be things like Joe went to the soccer game, and Joe played basketball. Joe attended Friday prayers. Joe keeps, to some dietary requirement or whatever. These are just behaviors that exemplify these various personality traits. And Klein and Loftus had subjects study these 20 behavior descriptions, just a list of sentences, okay, under one of 3 conditions. In the first condition, they were asked to study the sentences with the goal of forming an impression about the person being described, like how athletic he is, how religious he is, or whatever. In the second condition, they weren't asked to form an impression, they were simply asked to memorize the sentences. Okay, that's all they were asked to do. Forget about what Joe's like as a person, just memorize the sentences. And in the third condition, they were asked to sort the 20 sentences into various categories. Okay, that's all they were asked to do. They weren't asked to memorize them, they weren't asked to sort them at all. Then what Klein and Loftus did, after subjects had performed this test, they then surprised them with a request to remember the 20 behaviors that they had studied, and what they looked for was evidence of clustering. So for example, did subjects recall the 4 athletic behaviors together, the 4 honest behaviors together, the 4 sociable behaviors together, and so on. And the results were very clear. Here's a measure of clustering here on the y-axis, the 3 conditions here. When subjects were asked to classify the sentences, to sort them according to their